This podcast is on tubular organs, the second kind of organ besides solid organs. And so this information is on the note sheet right here. And so I have it listed, and then I have a drawing and an example for you. So the very first thing is tubular organs. You need to think of these like a hose, a garden hose, or a straw. They're going to have a central lumen going all the way through them so that something can go through, get pushed all the way through from one end to the other through the organ, okay? So now, what are some of the highlights for tubular organs? The tissues make distinctive layers, except for nerve tissue. So ET, CT, and MT come in very distinctive layers on slides, okay? And you can also sort of grossly see that when you look at the wall of an organ. So nerve tissue is the only one that doesn't make a distinctive layer. So we have two kinds of layers, terms for layers in the walls of tubular organs. If it's a large general layer, we call it a tunica. A tunica with a lowercase t is the abbreviation, and there's 5 of these in every tubular organ, okay? And then a smaller specific layer is called a lamina. And so it's abbreviated with a small l, and there's 3 of these, all right? So those are the 2 terms we'll use a lot, tunica and lamina. And lamina means layer. So when you laminate something, you're putting a layer over something else. And then number 2, they all have a central lumen that runs through the organ to move something all the way through, like food, like urine. Even eggs have to go down a lumen. And so that's by peristalsis for most things. And so basically, peristalsis is the slow rhythmic squeezing from smooth muscle. Great. And then the third thing that's true about all tubular organs, we have blood vessels, lymphatics, and nerves that come in and out of the wall of it like solid organs, okay? So very similar, actually identical. And then examples of tubular organs will be intestines, blood vessels, the bladder, uterus, trachea, and there are many more. So as we go through our different systems, we will always ask, what kind of organ is this? And then you can only say either it's solid or it's going to be a tubular. All right, so now let's look at how we're going to use these terms, tunica and lamina, in the wall of an organ. So on histology slides, you'll be able to identify all of these layers, except nerve tissue, never layers. All right, now over here, I have a drawing. And so on the very outside, there's a little thin layer of simple squamous ET always, never changes. And we call that little thin layer that's going to give it its shape, overall shape. We call it the tunica serosa. It abbreviates TSER. Okay, so all of this is on your note sheets also. Then we always have some kind of connective tissue under our ET, and it's usually 90% of the time dense reg CT. And so the other 10% could be dense irreg CT. And so I put some orange in here. So what do we call this general layer? We call it tunica adventitia. TADV is how it abbreviates. And also you can have fat in this layer. It's optional, okay? ACT is optional in the dense reg or dense irreg CT. Then our third big layer is the green layer, and it's smooth muscle. And so the muscle will go this direction, and then it wraps around this way. So you always have to have 2 layers of muscle, because muscle tissue works when one contracts, another will relax. And it's the same way in smooth muscle in the wall of an organ. So smooth muscle, you're going to have 2 to 5 layers of SMT to do peristalsis, the slow rhythmic squeezing. And so what do we call this layer? It actually makes sense, tunica muscularis, and it abbreviates TMUSC. All right? And now our 4th general layer is this orange layer that looks like scribble right here. And that's going to be dense irreg CT always, no exceptions. And so we call this layer tunica submucosa. abbreviates T sub-MUC, okay? Submucosa, or you can abbreviate it T SUBM, all right? So there it is, and so that's a very supportive layer in the wall. And then we have our 3 laminas, okay? And so we have a little bitty thin layer. Then we have the pink dots right here. They're going to represent the loose CT fibroblast always. And so you're going to have capillaries in this layer also. So basically the loose CT little layer is called lamina propria. It abbreviates L-prop, P-R-O-P. And then the last layer that's going to be around the central lumen, the space in the middle, it's going to be some kind of ET. This ET always changes depending upon which organ we're talking about. So some kind of specific ET will be lining the lumen. And so what do we call this specific ET layer? We call it lamina epithelialis, okay? And that will abbreviate basically LLEPITH. And so that's how it abbreviates. So if I'm talking about this is the small intestine or the large intestine, these would be simple columnar ET cells. If I was talking about the bladder, it would be transitional ET cells, right? And so if I was talking about the trachea, it would be pseudostratified columnar ET with cilia, right? So it's going to change depending upon the organ. Now, these 3 laminas, the lamina muscularis, the lamina propria, and the lamina epithelialis, they go together to make our last and 5th final big layer called tunica mucosa. TMUC is the inside layer of every tubular organ, all right? And then you'll also notice we have the same things. We have the same things as we did for solid organs. We have nerves coming in, nerves coming out, the afferent and efferent. We have arteries that are going to come in, become capillaries, and they're delivering the good stuff, oxygen, food, and hormones. And then they'll pick up the nasty stuff, the capillaries they'll pick up CO2, waste, and they also pick up hormones from the cells, and they'll take it out. And then we have to have lymphatic veins and capillaries that will pick up the extra plasma that leaks out of these cardiovascular, and so that will eventually return it back into your cardio system, all right? And so that's all going, you have nerves and blood vessels and lymphatics all the way around, just not on one side of the organ, all right? So those are the general layers and specific layers associated with all tubular organs. Now, I also made something to show you. And so right here is a very old little Milky Way, and it's very hard, at least 15 years in here, so it's very hard. And so this would be the lumen. And then putting our layers around, you're gonna have some kind of ET going around right here, and this is what's making the lumen, the ET layer. So that's lamina epithelialis. Then you always have to have loose CT with the blood vessels in it, the capillaries. And so this is going to feed the ET and support it. So this is lamina propria. And then you're going to put a nice little layer of muscle around 1 to 2 thin layers. And so now it looks like a sandwich. And so that's lamina muscularis. So these 3 layers go together to make tunica mucosa, which is always around the lumen with the food or the urine or the fecal matter or the sperm or the eggs, whatever you want in there, air. And so it would be in there. And then I'm going to put a supportive dense irregular CT around these 3 little layers right here, make it support. And so that's going to be called tunica submucosa, okay? So it's becoming more like a sandwich. And then I have to have at least 2 layers of muscle, smooth muscle, to do the peristalsis. And these are going to be much bigger layers, and they'll wrap around, and that's called tunica muscularis. And then I'm going to put some dense rag to make it like a ace bandage, hold all this together like that. And that would be tunica adventitia. It might have some fat in it. And then all of this will be wrapped, of course, with simple squamous ET going around the outside, holding it all together like plastic wrap. And that is always called tunica serosa. So when a surgeon makes their initial cuts on you, once the body wall is open, they always say this is a serosal. If it's a tubular organ, it's a serosal incision. And so serosa means he's going through the simple squamous, and then he's going to hit the dense rag all the way down into the where the lumen is. Right. So that's a little example of how the walls are made, constructed in all tubular organs.